Yeah, and so that would be the number of times it lands on heads.
Yeah.
Okay, part B.
The null hypothesis is H0. Uh, P is greater than 0.5.
Yeah. Hang on.
Oh wait, no, P is equal to
Yes.
0.5. Yeah.
And so, yeah. And so C.
C is P is greater than 0.5.
That's it. Number of times that lands on heads. That's it. Okay. So you already know that stuff. P equals 0.5. P is greater than 0.5. And its test statistic is X. Number of heads in 8 tosses. Test statistic, hypotheses, and sure. I'm just gonna. Now we'd better do it. Okay, how about this one?
Mm. The test statistic is 3.
3 what?
3 people.
Uh, no, that might be like no. So the last time X, it's like the whatever the X would be. So you can imagine if they flipped this coin and it landed on it 3 times,
Yeah.
X wouldn't be 3. In this case, X was just the number of times. Oh, I see what you're saying. Uh, but you have to like what you have to describe it in words, I believe.
The number of people who support the candidate.
Yes. Okay. B.
Um, um, P is equal to 0.4. And then the other hypothesis, P is less than 0.4.
Let's see if she's overestimating. Um, if she's overestimating, okay, and C.
Um, if the if the value is greater than 0.05, then the null hypothesis to be rejected. I think I always get confused about which way around it is.
Okay, so I think it's your final answer would have to be for that one. Let's see. So the null hypothesis will be rejected if the probability of 3 or fewer people saying the support candidate is less than 5%. It's basically because this is less than.
Oh,
That's where that comes from.
oh, okay.
And if it's greater than, then it's yeah the other way around. When it's greater than, you have to do the 1 minus.
Oh,
Yes. Okay. Any questions there?
no.
Okay. And that's something that gets lots of students to.
When you do the 1 minus,
Yeah.
it always confuses me because sometimes you have to do like 1 minus 1 less than like the actual number.
So
Then sometimes you have to do 1 minus like the number that you need, which I don't really get.
so try this one. I think you'll see.
The critical region. I forgot how to do that.
So the critical region, you could just test it out in your calculator.
um,
And are you using graphical or this one?
it's graphical.
I'll go with graphical as well. Then. Oops. Okay, so we're doing binomial distribution. And so just I would just do trial and improvement, really. Just try different values. And do you know what you're aiming to get?
You want it to be like 0.95? Or like
Yes.
the
Yes.
one that
Correct. Because this is greater than.
that would
Oh,
be.
excuse me.
But what if none of them are over 0.95?
Let's see. Simple observation is taken. Binomial. Are you using cumulative or probability?
Should be PD.
I believe it's cumulative, and that's because let's take in our previous example, if there had been 4 voters, then that would prove it. If there had been 5, that would also 6, that would also prove it.
Mm-hmm.
And so it's cumulative.
Okay. Now let's so the critical region is greater than 4, I think.
So x is greater than 4.
Greater than or equal to.
Okay. And b?
What's the actual significance level?
So what did you get, like 0.96, 0.97?
0.978.
And so you would do 1 minus that.
.022, which is, do you have to give it as a percentage or not?
No, you don't have to. But
Okay.
yeah, 2.2%, something like that. And so what were the values that you put in your calculator for this one?
Oh, I didn't use the stats mode. I just did it on the normal, like maths one. So it doesn't show you this.
So what is it? Menu
If you go on like the first one,
1?
yeah, and then you go option,
Yeah.
stat, and then distribution, and then binomial, and then you can pick. Then you just put it in brackets. So you put 6, 0.35, and then it gives you a list.
Yes. And you just look for the first one that is...
Yeah, if you press enter again, it'll give you like a proper list. Oh wait, no. You have to go like on the value and then
press up, is it?
yeah, like that. Yeah.
Okay. And then so you just find the thing. So it was when it was...
But because it starts counting from 0, you have to like add 1 to the number. I mean -1 to the.
Okay. Oops. So 5 or 6. Yes, I didn't think you would be doing that. Why is that? It is because, you know how we're doing 1 minus?
Why would we be doing 1 minus?
So because...
Greater than.
Yes.
Oh.
We are...
And this is less than. Oh, I forgot.
Yes. By default, the calculator is always less than or equal to.
Yeah.
And so when you do 1 minus 4, 5, and 6, what you're... 1 minus 4, 3, 2, and 1, and 0, I suppose. What you're left with is 5 and 6.
So
x is greater than or equal to...
wait, you know where you're at 4, 3, 2, 1? Is that like x is less than 4?
Yes. So when you
Okay.
put into your calculator like the 4...
Yeah, that's actually 3 though, because the numbers are wrong on the calculator.
Ba-da-bum.
Not to start from 1, but you have to start counting from 0.
So 3, 3, sorry, 8, 8. Yes, 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 yes. Let's see. So we wanted this one. So I don't know. So if you just look at it, basically 5 or 6, is that not the case? Let's see. Let me see there one. So assume hypothesis is true. X is going to be 1 minus 1 minus probably x is less than 3. No. This is this rubbish thing. Yes. This is part of why hypothesis testing I'm not a fan of. 5%. What they did was, or did they? Sometimes they'll do a thing where they'll choose the one that's closest to 5%, even if it isn't.
It just has to go under.
Yeah.
%.
Yeah. Okay. But sometimes they'll even do worse. They'll pick one that's close to the one that's closest to 5%, even if it isn't after. Okay, try this one.
This one is like you have to find like the one both ends, like on the. I don't know how to explain it, but like.
Yeah.
Because it's two-tailed. So it's 40, 0.25. So do you just, okay, 0.01. I'm not sure how to find critical region. I know it's like in between two numbers, but I don't know how to do it.
So if we do 40, 0.25. Okay. And we want, so this is the one, the probability in each tail. So basically because there's two tails.
Yeah, you have to half the.
You have to half it.
Level.
And let's see. So they want it to be as close to 0.01 as possible.
So x is less than or equal to 4. Sorry.
So that's one tail. How about the other end?
Oh, it has to be like 0.99.
Yep.
So it's x is less than or equal to 17.
Greater than?
Why would it be greater than?
So if this distribution, let's say, looked like that, you've got 1% here and 1% here. And so this one down here is 4 or less. This one here would be like 17 or more.
But on the calculator it gives you less than.
So, you know, for the first one, x is less than or equal to 4.
Mm-hmm.
Would, let's say, 6 be included?
No.
But if x is less than or equal to 17, then 6 is included.
Yeah.
Yeah. It's two-tailed.
So do you just not do 1 minus for this one?
I believe you do 1 minus, but it's greater than.
So you do have to do 1 minus.
For the second tail. So that's essentially what you're doing. So remember you said 0.99?
Yeah.
So essentially what you're doing is 1 minus.
Oh, okay. So you don't actually have to do 1 minus. But
what is 1 minus 0.01?
0.99. But you don't have to do like 1 minus the probability of something to find x is greater than. Like you don't have to do that.
Not 0.75 if that's what you're thinking. Like you just did it naturally. You said the other one is 0.99.
It's like probability of x is greater than like 4 is equal to 1 minus probability x is less than 3. Like, do you not I have to do that?
Um, uh, okay, do that, and what do you get?
I don't know.
Let's see. So we're saying that this one is very close to 0.99,
Hmm.
and so that matches up with 17.
Hmm.
So we're doing 1 minus. So if we did 1 minus x is less than or equal to 17.
But then that would give you x is greater than 18.
So x is greater than or equal to 18.
Yeah.
I believe that's it. So less than or equal to 4, greater than or equal to
Oh, so you do have to add 1 to the value, basically.
uh,
Like the value that the calculator gives you, you have to add 1 to it.
let's see.
Greater than. Not
For greater than, I suppose, yeah. I think that's just a quirk of this calculator, though, more than anything.
okay.
Yeah.
So okay, when it's two-tailed, you just don't use the actual number, but you use the number next to the calculator number.
Well, keep in mind that's only when it's greater than.
Yeah.
So,
Okay.
so let's
So if
see.
it was one-tailed, but it was greater than, what would you do?
Uh, then we would do what we did before, which was 1 minus.
Okay.
If it's
Because
greater
that
than.
one minus bit is like always confuses me, and I don't know how to do anything.
1 minus. It seems like it's more a quirk of the calculator than anything, and it's
The
because there's no
question
zero.
practice, some of them do one minus, but then some of them don't, and they're all greater than. So I don't understand when you have to do it and when you don't need to.
I'd have to see, but as far as I'm aware, if it's greater than, it's going to have to be 1 minus. Maybe it's just the wording of the question or something.
I don't know.
I just want to see something. So that's really 0, 1,
Yeah.
2, 3. They are saying it's close to 0.01. Is that true? Yes. You see, this is this nonsense. Technically, this number is slightly closer to 0.01.
So you
So,
would have to see which one is closer.
well, if it tells you to. This question said
Oh,
as
okay.
close as possible. And
Okay.
so this is this one that I don't like.
Never seen one like that.
Let me just see. The other one was 18. Yes, 18 to 40. I suppose.
Region is every. Okay. Well, okay. No, I understand.
Yeah.
I do.
And part B, write down the actual significance of the test.
Get that. Oh, that's just the value that you get. So would you write two values?
Yep.
So the first one, which is less than equal to 3, is 4.7 to times 10 to the minus 3.
So let's do this to 5 sig fig. So 4.69568. I'll just do it to more. 4.69568 times 10 to the minus 3. And then the other one?
Always have to do it to 6 significant figures.
Well, I just did it, had a natural cutoff point there. I suppose like I should do it to, I could do it like 7. It's because your final answer should be to 3 sig fig, and so the working out has to always be to 2 more,
Okay.
so that it rounds properly.
And then that one, 1 minus x is this. So you
Then,
know how it says 1 minus x is less than or equal to 17. So when you write down the actual level, would you have to do 1 minus x is less than 17, or do you just say the value for, like, the value on the calculator? You have to do like 1 minus 0.9953.
yes, because it is this tiny little region in here. So it'll be a number that's close to 1%. It'll be close to 0.01.
So you do have to do minus 0.9953.
Yeah.
Okay.
Minus that. And so what do you get for that one?
4.7 times 10 to the minus 3. It's just the same. Oh, okay.
you're rounding a lot, are you?
Yeah, but it's the same.
It's exactly the same, is it?
I think so. I didn't do. I only did 1 minus 0.9953. I didn't do more decimal places than that,
Okay.
but I probably could.
Well, it's probably because it's symmetrical. That's probably what's going on.
So
99.
it is be symmetrical.
It's not exactly. Oh, what did I do? Oh, I'm crazy. What did I do? 99535. 1 minus.
Yeah, it's 4.65 to the minus 3, which is what I'm getting.
Yeah. So
So it's not exactly the same.
that's a minus 3. We should just get one number, however.
Oh. How?
You would add these two together.
I've literally never done this, but okay.
So add those two together. What do you get?
I feel like our school does things weird, so we might learn this year. Because I didn't do this last year.
To the minus 3.
9.3457 times 10 to the minus 3. Yeah.
Okay, and that is very close to 1%, I believe. So,
it's 0.009. How's that close?
oh
Yeah.
I don't know.
That is close, but.
Okay, 5, 7. That's my thinking there. It is 1.63, 0.0. What was this other one? 0.0.
That's the one they got 1 minus. What? How did they get?
18. 9, 8, 8. Did that one bite us again? It did bite us again. It's because, you know the way it needs to be over 0.99?
Please confuse me.
No, I did confuse you. This is terrible, terrible question. So remember 18, sorry, this one was 0.9953.
Yeah.
That's
actually less than 17, right?
Yeah, which is 18 or more, which was correct. Yeah. It's just that the one before it is closer to 0.99.
Oh.
It's very, very close to 0.99. This one, yes, this was this terrible question that I warned you about. Okay, so you'd get those two and you'd add them together.
Okay,
it's the same method. This terrible thing. Okay, let's do some normal stuff. Let's see. So this is binomial. Okay, let's try this one.
20, 0.4. Yeah, I did it wrong. So x is less than or equal to 5. And then I'm still finding the second one.
Okay, and I'm just going to write it as x is between 0 and 5.
And then x is greater than or equal to 13.
Hold on. I don't believe this is two-tailed.
It is.
Oh, it is, sorry. Yep.
Yeah.
Were you... Okay, and then the other part, what was it?
X is greater than or equal to 13.
13, so that will be between 13 and 20. Okay.
Next level. Yay.
Did you do 2.5 and 2.5?
Oh, no, I didn't.
You're so quick with that calculator.
What's two? Would it be over 0.025? Yeah, it would still be the same.
Is it still the same?
It's still x is less than 4. Yeah, that's in the first one. I got the.
You said 5 less
It
than or equal to 5.
should be 4, I think,
Should be 4. Okay.
because of the weird numbers on the calculator.
Okay.
Because that's the first one that goes over 0.025, which I think is 0.5 divided by 2.
Yeah. So that's that. 0, 2, 5. Yeah, looks good. And then the other side.
0.025. I need to figure that one out. 0.975. X is greater than or equal to 13, which is the same.
75, which is 13. Great. And so 13, they're saying 3. Did they do that silliness again? Let's see. 4 is this one.
Yeah.
Um,
I thought you were meant to do the first one that goes over, like 0.025.
you absolutely are. Let me just see this thing. Because obviously 0 is less than that. Obviously 1 is less than that. Is it, did the question say pick the one that's closest?
No.
Nope. Let's see, 0.025. So they picked the one that's closest. I like R1. They didn't state it. That's a bad question on their part, once again.
Actual significance level.
Okay, actual significance level.
So X is less than 4 is 0.05095.
Okay.
And X is greater than 13. So you do 1 minus whatever that is. And then the other one is 0.02103, I think. I'm not sure if I did that right though.
Okay. What would you do next?
Add them.
Okay, go for it.
Zero 0.036991.
So was it 0.03?
36991.
991. And I think that they're going to add these two.
Oh, yeah, because that's the one they got for.
Is that what they're doing?
No, that's what we did. That's the one I did. That's the one they did.
Oh, so you just kind of corrected for that, did you? 2,
I don't
1,
know.
2, 3.
I did 15961 plus. I think that's
3, 6, 9, 9, 1. Well, oh, it's not the same thing twice.
yeah. I think that's the one that they did.
Okay, 3.7% either way. Yeah, they rounded it to 3.7%. Grand. Any questions about that?
No. How did they get 0.021 plus 0.016?
2, 1, 1, 6. So there's the 2, 1. There's the 1, 6.
Oh,
They
still,
rounded very.
you do have to find the one that's closer then. Or,
Well, that's something I'm gonna have to look into. But I mean, so technically, no. I mean, is it in the critical region? Like, it's less than 5% confidence. Sorry,
we didn't do that when we learned it, so I'm not sure if we should.
It's greater than 5% confidence if we go. No. It's less than 5% confidence if we use their one.
Oh, is that what it's meant to be?
Sorry, it's less than 95% confidence. So it has a greater than, less than 5% level of significance. But no. They're just going by whatever's closest.
Okay.
So they're snaking us. Let's see. Find the critical region. So this one is as close as possible. So it seems like they're just inconsistent with naming it. What I'll have to do is I'll just have to look up the actual past papers and see what they came up with and what the examiner report said.
Also, how do you know when you're meant to reject the null hypothesis and when you're meant to accept it?
If it's outside the critical region. So let's say in the previous one, if you got one of, let's say, 5,
Yeah.
then you would be keeping the null hypothesis.
Okay.
But if it was in between, according to them, 0 and 3 and 13 and 20, then you'd be rejecting it.
And then, like, when you don't have a critical region, how would you do it?
You could find a critical region first, or you could just go by your calculator.
So how do you know?
So hang on. So this is more the same. So you can do those questions. I'll have to find the critical region, write down the actual significance. Okay. Describe the test statistics. Find the critical region of incorrectly rejecting. So that would be kind of just straightforward thing for do we reject it or not. Okay. Claim made by the doctor. Oh, so this is when you reject or accept. Yeah. Okay, let's try this.
So the null hypothesis would be P is equal to 2 over 5.
Yeah, I'll see a 0.4.
And then the other one is P is greater than or equal to 0.4.
Just greater than.
Do you not do greater than and equal to?
I think the chance of it being exactly 0.4. No, because 0.4 is in this one.
But doesn't your calculator like give you, even if you do 1 minus, doesn't it give you greater than and equal to? Greater than or equal to?
I'll take your word for it. See, I think it's because 0.4 is this one, and so if you do or equal to, then you just have equal 0.4 in both of them.
Oh yeah, that's true.
Excuse me.
Okay. So then you do. So then you would put 20 and then 0.4. And then do you find the probability that x is equal to 11 or greater than 11?
So we can go down to 11.
But would it be greater than or equal to? Would it be the probability that x is equal to 11 or probability that x is greater than?
It would be 11 or more.
So it would be greater than?
Yeah,
okay.
Greater than or equal to.
So it would just be the value next to 11 on the calculator?
It will be relatively close to 5%, which 87% and 94% are not.
Because the calculator is like 1 minus, so it is 10. It's actually x is less than 10.
Yeah, so we have to do 1 minus the probability that x is less than or equal to 10.
Okay. So 1 minus 0.872. 0.1276.
76.
That's greater than 5%, so the null hypothesis is rejected.
which is greater than 5%. Therefore, the null hypothesis, I believe, is not rejected.
Oh, I don't know. I get mixed up with.
Not rejected. So basically,
If it's like the same as the alternate hypothesis, then you accept it, right? Is that
we want the significance level. The smaller that number, the more significant. So the opposite of it would be a confidence level. So if it has 5% significance, then you can be 95% confident.
okay?
If it's 1% significant, then it's 99% confidence. So we are like whatever it was, 87% confident, which isn't 95% confident, and so I believe we would keep the null hypothesis.
Okay.
12.75.
But just like to help remember it's the same as the alternate hypothesis. So if it's like greater than, and then like it's greater than 5%, then you reject each
Yeah,
and
that's
if
good. That's good. I never thought of that. Yes, so if it's greater than the significance, then you
reject H.
keep. Then you keep H null.
No,
So
it says reject.
there is not enough
Okay.
evidence to
Okay.
reject. Yeah,
That's confusing. Why?
yeah. Double negatives. Not enough to reject. So the new drug is no better than the old one. So that would have to be like 4% or something like that.
Okay.
Okay, we'll try another. Oh, here's a method 2. So here with method 2, they found the critical region first. The critical region was 13 or more. 11 isn't 13 or more.
Okay.
So before we were finding the critical region, you can find the critical region if you want and then use that, or you can do it directly. So let's give this one a go.
So the null hypothesis is P is equal to 0.4. And then the alternate hypothesis is P is greater than 0.4.
Okay.
Find the critical region. Okay. So it's one-tailed and it's greater than. So you would find the one that's over 0.95. Is that how you do it?
Yep.
So x is less than or equal to 12.
And so what do we... this is a greater than question.
Yeah. Wait, well, I'm really confused now.
So it was 20 and 0.4 again, was it?
Yeah.
Oh, okay, that's a coincidence. Let's see. So 0.95, and that is there. So the x for this one is actually 12. Is that right?
That's what I thought. But then you said it's greater than, so it would be 1 minus 12.
Yeah. So 1 minus the probability that x is less than or equal to 12. And so what x remains?
Like what the probability is, or x is greater than 13.
Something's missing.
The greater than or equal to.
Yes. And for the sake of clarity, I will write it as between 13 and 20.
Do you have to write it like that or not?
Well, technically, x is greater than or equal to 13 would include 21, but there's only 20 seeds.
Okay.
Okay, and then part B.
Is in the critical region, so you reject the null hypothesis.
Correct.
Okay.
The critical region, therefore reject null hypothesis and accept the alternate hypothesis. Let's see. Yep.
Paragraph to memorize on like how you write the conclusion
Yeah.
for a hypothesis test. You literally have to write that.
Yeah. 14 lies within the critical region, so we reject the null hypothesis. There is evidence that the new technique has improved the number of plants that germinate. Great. Any questions there?
I still don't really get it, but
What do you not get?
it's like the whole thing, like how to find the critical region and then like how to like know whether to reject and accept, and then how to like when there isn't a critical region. Like I'm just confused about the whole thing.
I mean, you just did it. There's nothing more to it than that.
But like it's confusing.
So I think the 5% level of significance, I think of it as 95% level of confidence. So this one,
Like I know how to do it, but like it's really confusing.
try this one. I won't help you at all, and I'm sure you'll get it fully right.
The test statistic is how many people support the candidate.
Okay. Okay, go on.
The null hypothesis is p is equal to 0.35, and the alternate hypothesis is p is greater than 0.35. Okay, critical region time. So it's critical region is x is greater than or equal to 24. So it's in between 24 and 50.
Okay.
And then 28 is in the critical region, so the null hypothesis is rejected.
Yep. And that's BL. There's enough evidence at the 5% level of significance to accept H1. Okay, let's check. X is greater than or equal to 24, so ours is better. Let's see, that was 0.1, that's greater than 10 lies in critical region, so reject. So basically, yes, it's the number of people who support the candidate. Okay, yep, that's all exactly what you said, I believe.
Like I know how to do it, but like I still get confused because I think it's because last year I literally did not understand it at all.
I mean, I'm throwing these.
I just left it, and I shouldn't have done that.
You just what? Sorry.
Like
Oh,
I
you
just
just
like,
learned it.
relearned it. Like I didn't get it last year, but like I just left it. I didn't do anything.
There's nothing more to it. It's just you could
I
do
just
it.
don't like it either.
You could do it using like the choose stuff and choose.
I
Oh,
do like oh I don't like that. I think if I do like more practice, then it might help.
yeah. But I think it's like, I mean, you got to fully correct. You know.
And I literally hate stats, so it's not really helping.
Stats. I fall in and out of love with it. So this is a two-tailed one. Could try this one.
So uh, the null hypothesis is P is equal to 2/3. And then the alternate hypothesis P is not equal to 2/3. Then you do percent. So the critical region is x is less than or equal to 4, and then and x is greater than or equal to 10.
Okay.
So it's 10. 20. Wait, why would it be between 10 and 20?
Oh, sorry. This one doesn't go to 20. Just 10. So x equals 10.
Yeah, I think.
Okay.
Then the test statistic is in the critical region, so the null hypothesis is rejected. So the number of people in Manuel's restaurant is not different.
Okay.
In Enrique's restaurant, I think.
Yeah, and we can be like 95% confident in that. Let's see. They're saying there's insufficient evidence to reject null hypothesis.
Yeah, I did the probability wrong. I did the hypothesis part wrong. That's why.
What part did you do wrong? 2/3, 1/3.
It says 1/3, and I did 2/3.
For what, the null hypothesis?
Yeah, and the alternate hypothesis.
Let's see this one. Over a long period of time.
The question properly.
So non-vegetarian to vegetarian. So non-veg. So that's basically meat.
Yeah.
Is 2/3.
And veg is 1/3.
And
I'm gonna do this again.
okay.
So it's actually x is less than or equal to 1.
Okay.
I think. I'm not sure. And then the other end is. Wait, what's 1 next? Is 7 to 10 is the next one.
7 to 10.
So it is in the critical region. So you reject H naught.
Okay, so we reject H null and all that. They're saying it's insufficient. Why is that?
H naught. Oh.
X is the number of people in sample. 1/3. Significance 5%. Did I have these backwards or something? Method 2. Excuse me. 7.
How did they get 7? Oh wait, that's what I got.
You got 7 to 10. But they found, what was it, one person, was it?
Yeah.
So that would be looking at the other one.
That'd be in the critical region, right? This
So
is the
0.1. They're saying that
this is
that's.
the wrong method. I
Sorry?
mean, the wrong method, but a different method.
What method did you use?
Critical region.
Should be nothing wrong with that.
The second method too. It's like I think it's on a different page. It's critical region.
Yeah, nothing wrong with that. Hope I just did the. Are these same numbers as yours?
Um.
Yeah, they should be.
Yeah.
Okay. So we wanted for 2.5%.
Hmm.
So 0 and 1.
Yeah. It would be less than 1, right?
No, it should be 0 or 1. I'm just thinking, what?
Oh, 0 or 1.
Da-da-da-da-dum.
If you go, I think it's on the next page. There's like they did it with critical region. Yeah, this one.
The observed value of 1 does not lie in the critical region. Where's the lower critical region here?
0.
Let's see what would be the critical region. 0.025 for the lower tail. 0.104.
Yeah.
Ah, yeah, that's 10%. That's much bigger.
Then you want it to be bigger.
No.
You don't want to be over 0.025. Then you want the first one that goes over
So
0.2.
what's the first one as a percentage?
1.7.
Second one as a percentage?
10%.
Yep. So
But then you want like the first number that goes over 0.025.
no, just the ones that are less than it.
Why would you want the ones that are less?
That's what we've been doing this entire time.
I thought we were doing the first one that goes over it.
Oh, I think maybe you're thinking of when it's greater than. No.
Understand.
So okay, why not the second one that's over it, or the third one that's over it?
First one.
So this one is 10%. So that's you would be 90% confident. See what I mean? We want a much smaller. We want a much higher level of confidence, like 95% or 97.5%.
Find the critical region then.
So for this one, the critical region is 0. So your second part was fine.
But I don't understand. How do you find the lower tail then?
Oh, you and your lower tail. Okay, hang on. Do we have another one? 5%. The probability is close. See, it's always as close. I don't want one that isn't as close. 10% less. This one. 1 out to this one. Okay, lower tail for this one.
So the null hypothesis is.
Don't worry about that. Just
Oh, okay.
lower tail.
Lower tail. No.
What lower tail did you get for this one?
0.
I believe actually it's empty, so even 0 isn't enough.
Okay.
Because, yeah, there is no lower tail.
Okay. So if it's 0, there is no lower tail.
Yeah, because that's 12%, and we needed it to be 5% or less.
Okay.
Grant, how was?
I get it.
You're getting a plenty. You're getting a plenty. Like there's no.
It's not over. Like for this one, for the one we just did, it has to be over. Like the first one, that's over 0.1.
Not the first one that's over.
Yeah, but that's 0. So that's why it's 0.
Uh,
T.
for the previous one, 0 was included because that had less than 2.5%.
Yeah. So wouldn't it be less than 1 rather than less than 0?
Less than 1 is the same as less than or equal to 0.
How? Oh,
So
wait, for that one. For this one. If it's, I think, one sec. But wouldn't it be X is, like, the critical region, wouldn't it be X is less than or equal to 1? Like the probability.
um,
Like what? I don't understand why it's not.
so so you've got 2.5% here, 2.5% here.
Yeah.
Probability of x being 0.
0.0173.
So 1.7%.
Yeah.
Is that in here?
Yeah.
Probability that x is 1.
10%.
And so is that in here?
No.
Nope. So 1 is in here, x being 1 is in here, x being 0 is in here.
So it's not the first one that goes over then. So then how do you find which one's the critical region?
The critical region is the one that is 2.5%, half of that one. 2.5% or less.
Or less, okay.
97.5% or more.
It's always 2.5 or less.
No. In the next question, they
I mean,
wanted,
it's always less then.
yeah, always less.
Okay. I don't know
Grand.
if we got told to find that then. I don't know. Maybe I just don't remember how to do it.
Well, you did all of that anyway. I think maybe what you're confused about is binomial distribution in general. Binomial has two things.
That sounds right.
Binomial has two things, so it can either be a cure or not a cure. It can either be. So I think maybe you just need to do binomial distribution in general. So like, it has to have large number of trials, fixed probability,
Yeah.
two possible outcomes. Sorry, fixed number of trials, fixed probability, and two possible outcomes. We can do binomial distribution next time if you want.
Is it different from hypothesis testing? There's another topic.
It's very different, but it's has similar stuff.
I don't even remember this topic, so I think we should do it next week.
Okay, binomial distribution. Gregoire, your classmate, did it last time, I believe.
Yeah, I know him.
Uh,
He's class. We have
uh,
the same bad teacher, so
all right.
this year. I wasn't with him last year, so I don't know.
Any questions for me in general?
No, thank you.
All right. Well done, Amogha. You did great. I look forward to chatting again next week.
Bye.
Have a good week. Goodbye. Thanks.